Okay, so today what we're going to be doing is we're basically going to say, now let's look at that slope of the tangent line, which we talked about yesterday, and we're going to call that the derivative of the function. So when I look at the definition of the derivative, we could say that it's really going to represent the slope of the tangent at a specific point. It's the instantaneous rate of change of a function at that specific point. So one of the ways we can define the derivative is we can use this, we can say f prime at a. This means the derivative. This is one notation for the derivative of a function, where we just use the little apostrophe up there. Is found by taking the limit as h goes to 0 of f of a plus h minus f of a all over h. This is at a specific point. I also talked about the fact in general we can have the derivative function written as the limit as h goes to 0, and then we just use an x for the a. So it's f of x plus h minus the f of x all over h. If you do that, that's in red, that's going to give you the derivative of the function anywhere, which ultimately will tell us the slope of the tangent line anywhere on the curve. The only thing you'd have to do then is plug in an x value once you got the equation to get the slope anywhere on the curve itself. So that's the general derivative. We also talked about the other form yesterday, which is down here. And this is when you're taking a value of x and you're approaching an a. And this is also the derivative. It gets you the same result. So as x approaches a, it's f of x minus f of a all over x minus a. And that method right there, some people find easier, I guess, at some points. It doesn't matter, but you do need to be familiar with all of these forms. So you want to make sure that you are familiar with the different forms you see. Let's go ahead and look at some of the examples that we're going to see here. Well, on this next page, we basically have two diagrams just to show you again of how the formulas come up. And really, they come up based upon starting with a secant line. This secant line is in blue from 2 points. And then you take the limit, as in this first case, as h goes to 0, and that gets you to a single point, which then tells you the slope of the tangent line. So the derivative is the slope of the tangent line. It's exactly like what we talked about yesterday. The second form that we had, that's when the x approaches a. Take the limit as x goes to a. Again, we're forcing it down to one single point, which is then the tangent line. Slope of the tangent line is the derivative of the function. Then we use the point slope form of a line to write the equation of the tangent line. This is the point slope form. Some of you might remember it as just y minus y1 equals m times x minus x1. Same thing. So let's go ahead and look at a couple different examples. First of all, let's see here. So on this one, we're going to just change the problem a little bit. We're going to say f of x is going to equal x squared plus 3x plus 5. And we're asked to find f prime at a. And when they do that, they want you to basically find that in general in terms of a. So if we're going to be using the definition, we have to decide which form we're going to actually use. So let's use this first one right here, with the limit as h goes to 0. So the first thing we need to do is make sure we set this up correctly. So we're going to take the limit as h approaches 0, and then where do we put this a plus h? In for all the x's. So it's going to be a plus h squared plus 3 times a plus h plus 5. So all I did is I put in a plus h in for each of the x's in the equation. Then I need to subtract f of a. Well, what would f of a be? How would I get that? If I want f of a, what do I put in for the x's this time? A. So that's a squared plus 3a plus 5. So that's the first part. And then on the bottom, I still have this h. So that's my setup initially. Then what I want to do is I want to go ahead and use my algebra skills, expand this and simplify. So I rewrite this as the limit as h approaches 0. And now I need to start to expand the top. So when I FOIL this a plus h squared, I'm going to get the a and I'm going to square it. So that's a squared. What would the middle term be here? 2ah. 2ah, because that's the FOIL, plus the h squared. Then I distribute the 3. So that gets me 3a plus 3h plus 5. Then I also distribute the negative. That's negative a squared minus 3a minus 5 all over h. Now normally what happens when you do this correctly, certain things are going to just drop out. So what's one thing that's going to drop out in this case? The a squareds. So the a squareds drop out. The 5s drop out. And the 3a. So that's really nice. And then I try to use direct substitution, but I still have a h in the bottom. What would be my next step? Yeah, factor it. So you rewrite this as a limit as h goes to 0. We're going to take out an h on the top. So that would give me 2a plus h plus 3 all over h. And then you can drop out one of the h's. You can put in 0 in for the h that's still left, and you end up with 2a plus 3. So the answer to this problem is that f prime at a equals 2a plus 3. That's the derivative of the function. So the derivative is going to be 2a plus 3, and whatever a value you have, you just plug that in, and that gets you the actual slope. Now, just so you're not confused about this, if we used x's, it's the same. Instead of a, it's the same thing. You would just get 2x plus 3. But because they specifically asked for f prime at a, that's why we use the a. If they just said f prime of x, then you use x instead of a. It doesn't really matter what variable you use there, but technically speaking, because they originally in the problem said f prime at a, that's why I use the a in the problem itself instead of an x. If they just said find the derivative in general, then just use an x. Use the x, and then you get an equation in terms of x, which is the derivative. And that's most of the time, that's what we'll do. Questions about that piece so far? Lots of algebra here, but it's the setup that you got to get down first, and then deal with the algebra, simplify, and then understand what that tells you. Toward the bottom it says, tell what f of x is used and what value of this limit definition of the derivative is using. So this is what I was starting to talk about with knowing and understanding the different forms of the derivative. When you look at this problem right here, and this might be something that would come up on a multiple choice question. They'd say, okay, this is a limit problem. What is that really telling us? What's it telling us? So if we recognize this format, we can say, well, that's a derivative. It's a derivative of something. And we have to determine then what function that's going to be. So if we kind of recognize the format, this looks a lot like the limit as h goes to 0 of the f of x, or let me use x this time. It doesn't really matter if I use x or a, but I'm going to use x plus h minus the f of x all over h. Now this is what it kind of looks like. It represents the definition of the derivative. If I look in this case then, and I'm trying to match this up, what do you think my x value is going to be? If you were to take a guess. Look at where the x, there's an x plus h. What's with the h? 16. So it appears as if the x is 16. Okay? Then if that's the case, what do you think the f of x would have to be? What did we do with the x plus h? We did the fourth root. So I believe that the f of x is the fourth root of x. Now we can test this by taking the fourth root of 16. What's the fourth root of 16? 2. And that's where they have this minus 2 right here, because that's the fourth root. 2 is the fourth root of 16, because we're subtracting f of 2 in the formula. So after you figure that out, then you could say that this formula, the limit as h goes to 0 of the fourth root of 16 plus h minus 2 over h is the same thing as the derivative of this function at what value? At 16. So it's the derivative at 16 where f of x is the fourth root of x. That's what that's telling us. And when we get to the multiple choice and we start practicing some of these things, we're going to see that type of thing show up. And then what they're expecting us to do is to recognize that that's the derivative of the fourth root of x at 16. And then we would have something that we'd have to answer related to that. But that's what that's doing. It's going backwards and trying to identify the function and identify the x value that we're plugging in to see how that works. Okay, on this last page then, what we're supposed to have here is we're supposed to have, you're missing a couple pieces of information. I'm going to add it to the diagram. At 2, we get an actual point. So at 2, we would have 2, comma, and if I don't know the function itself, what would I put in general for the y value? F of 2. So 2 comma f of 2. So this is like in general that specific point on the curve. Now let's go over a distance of h. What would my new x value be then? 2 plus h. And then we would be able to understand what the ordered pair is on the curve itself. So on the ordered pair, what's the x? 2 plus h. And what's the y? F of 2 plus h. Okay. Now, if we were going to try to compute the derivative at 2, what we would do is, if you think about this, we would connect these 2 points to create a black line, which is our secant line. So now, if we were to just look at the slope of the secant line, what would we do to calculate the slope of the secant line? How do you get the slope between these 2 points? Change in y with change in x. So I have y, which is f of 2 plus h minus f of 2 over 2 plus h minus 2. Okay? Now when I take 2 plus h and I subtract 2, what does that turn the bottom into? Just an h. So really what we have down here is just an h. So I'm going to get rid of the 2's. So we got an h in the bottom. Now what I see right now in black, that gives me the average rate of change from 2 to 2 plus h. That's also the slope of the secant line. If I want to then calculate the derivative at that point, then what do I need to do with this fraction? Take the limit. So now this is where the limit comes in. I take the limit as what? As h approaches 0. Now once I do that, then what does this represent? The derivative, the first derivative of this function at 2. Now, remember, when we talk about the first derivative at 2, f prime of 2 is the slope of the tangent line at x equals 2. That's what that means. It's the slope of the tangent line at x equals 2. So there's a setup using the h goes to 0. And that's how we could figure out what that's going to be equal to. Questions about that piece?